Hello guys, with this video I would like to start a cycle of videos devoted to algorithms, and just a couple of words about that. Knowledge of algorithms is vital knowledge for any software developer, even though in real life you will barely use any of them. I mean, of course you will use them, but not you will not implement them directly very often. But anyway, knowledge of them is first of all is your vital part of your success as a software developer. First of all, because you will be very often asked on interviews to implement some algorithm or to show at least knowledge of them. And second, knowledge of such a basics as algorithms definitely will give you some insights how everything works in software development world. And even though I have for now already 7 years or even more, already 8 years of experience, I in my life implemented only a couple of times algorithms from zero. And since we learn together on this channel, I'd like to refresh my knowledge and implement a couple of basic algorithms from the scratch. And today we will start with a simple yet powerful sorting algorithm called merge sort. So basically, if you would like to know more about this, please take your time and read about that on Wikipedia or in thousands of other resources. But I will explain you just very simply. So basically, whole idea of merge sort algorithm is this so-called strategy divide and conquer. So any algorithm using this idea of divide and conquer basically tends to split something, so divide, then do something on the divided parts, and at the end get some result. So basically, merge sort algorithm, how it works: we have some array, some collection of elements to be sorted. So let's make it simple and take an array of integers, for example. Then we cut it on half, and then for every half we continue splitting it. So we split until we have only one element in each the sub arrays. And then after we have this level, when everything is split up to one element, we start with second part. We start with merge. So basically, how do we merge it? Quite easy. We just while merging, putting smallest elements to the left side and the big one to the right side. So basically, after every merge, we have sub-sorted, already sorted sub arrays, and then we just continue merging them until we merge everything into one big array with the same size as the input array, but already sorted one. So as you can see, this algorithm has two vital parts. This is divide part, when we split algorithm, and basically mostly always it's done recursively. And the second half of the job is merge part, when we merge already sorted sub arrays into sorted another sorted sub arrays, and then eventually into sorted array. So that's the idea. Yeah, the complexity of this algorithm is n multiplied with logarithm from n. So that's the logarithmic dependency of time from amount of elements in an array, and that's quite good performance, which is sufficient for big arrays. We will see with you then what will be the performance of this algorithm. So here I have the new solution, brand new solution in my Visual Studio 2015 Community Technological Preview Edition, but doesn't matter, you can create it in any one. It doesn't use any advanced feature. So let's start implementing that. So let's imagine we have some input array and let's create some input array of random values. For this, to do it, I create a random object which will help us to generate random values. And let's generate enumerable range. I don't know. Okay, let's start from 10, so we can see if it was correctly sorted and so on, but then we will eventually increase it. And let's use the link U to generate the elements of array. Okay, let's generate these elements in a range from 1 to 1000, doesn't matter. And let's create auto with list. Good. So now, what do we want? Okay, let's show first on the console the not sorted array. Let's join it by some enumerator, by some delimiter like empty space, so we can see the unsorted array. Then what do we want? We want to sort it. Let's create some extension method merge sort, which we don't have yet, but we will have it. Then we will output the sorted variant, and eventually we will see if we will implement it correctly. So basically now our task is to implement this merge sort. Let's implement it as a extension method. So for this we will create public static class. Let's call it sorting extensions, because here we will implement more than one algorithm. Today only one, but in the next lessons it will be more. And here let's implement extension method public static merge sort. So who doesn't know, guys, that's a way how to implement an extension methods to any type. Basically you can extend any type which you want. Let's make everything simple. I don't want to work with arrays, I want to work with lists. But of course you can create your method for arrays or for collections or for whatever. I will make it simple. Here we have a list and the extension method will be for list. So let's start with a border case. If our input is null or come on, or our input count equal to 1, then basically it makes no sense to do anything. Let's just return from this method. So okay, now when we are sure that our input has at least 2 elements, let's start implementation. So well, how do we proceed? So basically, let's find some element. Let's call it middle, which will be the element in the middle of our array, and that will be not the element, but the index of element in the middle of our array. So we have a middle index. So then let's call it middle index. So what do we want? We want now 2 subarrays, everything what is left from middle index and everything what is right from middle index. So let's create one subarray or sub collection which is left from middle index. Let's use take method from linQ, which is included by default to any project, system linQ, and has method take. Actually, we want to take so many elements which are from which form the left side of the array up to middle index, and we want to take everything what is from the right side of the array. Also, let's use method which is called skip, which will skip so many elements as we want. So basically, we want to skip everything what was taken already by first subarray, and the skip, it bypasses specified number of elements in a sequence and returns the remaining elements. So basically, with this first one, we take first, for example, I don't know, 5 elements, and with the skip, we skip this first 5 and return another 5 if we have an array of 10 elements. So now we have 2 subarrays, everything what is left from our middle point and from right from middle point, and as you remember, we need to, as you can recall from our slide, basically you cut it on a half, then you continue cutting it, cutting until the element size, array size is 1, and then you start to merge it. So basically it means that we need to perform our merge sort on the left side, which will continue cutting it recursively, and we will need to apply our merge sort to the right side of an array. Good. And then once we come to the point when input count is 1, so we don't need to proceed further and split more, we will implement the merge step. So let's implement here the method merge. No, I don't want, I want merge, which says that, okay, we'll give parameters like the left subarray and right subarray, and let's give the final input as a parameter. So basically here it will be the method merge, which has as a parameters a list of int. I recall I implement everything very simple. I don't want to deal here with arrays and calculate this indexes and so on. That's why, of course, maybe this implementation not the best, but that's just to get the big idea how the merge sort is working. And here we have the right, and basically the input. We will see why we need it. I am not completely sure that it's correct, but we will figure out how to do it correctly. So basically, what do we want? We know that now we have subarray left, which is left of our merge, and that's already sorted, because it comes to this point only when we cannot split anymore. It means it will come to this point only at least when input count is 1 or more, and the subarrays which will come to the merge method will be already sorted. Good. So what do we do then? Let's calculate a total count of operations which we will need to perform. Basically, this total count will be the size of left array plus the count of right array. So what it means? It means if left array contains 4 elements and right array contains 5 elements, it means we will need to perform 9 operations in total, yeah? Good. Also we will maintain the left pointer which will go through left array, and we'll maintain right pointer going through right array. So let's implement for method. Here we'll have some I variable which should be in total less than total count. Good. So what do we do? Basically we ask if our left pointer is already more or equal than size of a left element. So it means we don't have already nothing in left. It means we will take only from right. That's also the H case. It means that in input the array, we will set in the position I something from the right. From the right. So that's the case when we already running out of elements in the left subarray, and it's obviously that everything what we need to do only take elements from right. So opposite is when the right pointer is more than count of elements in the right subarray. It means that we should take value from the left subarray, and increase left pointer after that. but that's the edge cases. Let's write like that. But in normal case, we would set the element, and we would ask if the current left element is less than current right element. If it's less, then we would take the element from the left array. Good. Otherwise, obviously we would take the element from the right array. Good. So that's basically it. Let's run our method and check how it's doing. Yeah, so good. So what we can see, first line, that's a randomly generated array, not sorted, and bottom line is the same element but sorted. So everything looks correct. Yeah, everything is sorted, everything is perfect. So guys, basically that was the merge sort algorithm. Once again, which uses divide and conquer paradigm, and is quite fast, has n log n processing time. In the next lesson we will check quick sort algorithm, which basically has the same time dependency from the number of elements, but performs anyway much faster. Stay with me, subscribe to my channel. That was Max with the merge sort algorithm. So if you didn't understand something, just take a look at this code, try to implement it yourself, try to understand what's going on, try to optimize it, because this implementation is definitely not the best, and just optimize it and check, and be sure that you understood every single line from that algorithm. Thank you for watching. Bye bye.